Hi everyone. So this is going to be a video where I'm going to demonstrate and talk about how we can perform reflections, and then also on the back side you guys have for translations too. We're not going to do rotations through video because it's a little more challenging, but reflection and translations are two pretty easy isometric transformations that I could talk about over video in terms of how we actually perform them, and then a little bit of the notation here. Okay, so if you guys remember, to reflect something means kind of just like to mirror it over or flip it over. Okay, so for number one, if you guys aren't familiar, these like little dots here that you see, it kind of looks like it's almost like a coordinate grid, right? But since they're dots and not an actual X and Y axes with numbers, we call it patty paper. Okay, so some of you might be familiar with that, some of you might not be, but it's just an easy way you can actually perform the different types of transformations. Okay, so number one says reflect the following over the given line of reflection. So for my first one here, I have my shape NOUM, and it wants me to reflect it over this vertical line here. Now, when we perform reflection, simply you guys can be making your image right over that line by plotting your image points in equal distance in the opposite direction. So for example, my point O is one dot to the left. That means O prime is going to be one dot to the right. Remember, we indicate the prime to actually say that, okay, that's my image and not my pre-image. So here's my pre-image. What I'm going to be sketching out over here is going to be my image. Okay. Now point U, it's two dots to the left. So U prime will be two dots in the opposite direction to the right. Okay. N is one, two, three dots to the left. So N prime will be one, two, three dots to the right. And then M is one dot to the left. So M prime will be one dot to the right, and then you've got to connect your dots similar to how they're connected in the pre-image, right? So your shape should look something like that, okay? And you can usually tell whenever you guys do these transformations whether or not you've done them correctly, because it should look like it kind of just got flipped over the line, right? Now, for your next example, notice how your shape actually kind of is intersected within the line of reflection. That's okay, okay? I'm just going to still follow that exact same process. So let's say for point Q is two dots below my line of reflection. So Q prime is going to be 1, 2 above. Make that Q prime. Okay. J is one dot above. So J prime is going to be one dot below. And then P is two dots above. So P prime is going to be two dots below. And if you're having trouble about how you should connect them, we'll kind of try following the order of the original pre-image, right? It goes J, P, Q, or J, Q, P. So I want to connect J to P and J to Q. So J to Q, J to P, and meaning I have to then connect Q to P, and it should look like it's overlapping a little, something like that, okay, more or less, all right? Now this last one here is tricky, and students tend to struggle with it because now your line of reflection isn't vertical or horizontal, it's kind of slanted, it's diagonal, right? And the trick that I always tell students is you can actually just turn your paper and make it so that that line is now vertical up and down, okay? It's gonna be easier to count your dots across. So if I'm looking at this line being vertical up and down, my point S is one dot to the left, so that means S prime is going to be one dot to the right, okay? T is also an easy one, so T is one to the left, so T prime is going to be one to the right, and then R looks like it's 1, 2 to the left from here, so 1, 2 to the right is going to be R prime. I'm going to connect my dots to make that triangle, and then when you turn your paper back, right, it should look like it evenly got reflected over. If you guys don't tilt your paper, right, and you can still kind of visually see the reflection over and you can plot your points, that's fine. But typically when students don't tilt their paper and they try doing it, your triangle ends up all over the place. You want to make sure it looks like it's mirrored over, okay? So that's just sketching out some reflections. Now section 2 says determine the pre-image coordinates, then reflect it and determine the image coordinates. So for A, B, C, and D, they're just giving you the points on the coordinate graph here, A, B, C, and D, and they label them, right? So point A over here, that's labeled as -2, 5. Let's just check that out. That's -2, 5. Yep, that's correct. Point B is 5, 7. So over 5, up 7, that's point B, that's correct. C is 3, -4. So 3, -4, here's point C, that's correct. And then D is 4, 4. So 4, 4, that's correct too. So these are just them listing out the points for you guys that are already plotted on the coordinate grid here, okay? And now our notation, okay? So anytime you guys see a capital R And then you have like a little subscript of something written. So you're going to notice in these examples, you have x-axis, you have y-axis, you have m and x-axis. That just means what you're reflecting that point over. So when it says r x-axis A, that means you're going to reflect point A over your x-axis. So actually, I'm just going to write that down here. So I'm going to take this example, r x-axis, and then in parentheses, A. In English translation, all that means is I am going to reflect point A over the x-axis. That's what that means there, okay? So if I go and look for point A, and I know my x-axis is a vertical line down here, I'm just gonna reflect it over. So again, kind of like how you guys did on the patty paper above, if point A is 1, 2, 3, 4, 5 units above your x-axis, that means A prime is gonna be 5 below in the opposite direction, right? So 1, 2, 3, 4, 5, and I'll list that as A prime, and that's gonna be considered -2, -5. So -2, -5. And if you compare the pre-image and image point, right? A is -2, -5, and then A prime is -2. Sorry, A is -2, +5. A prime is -2, -5. Aren't they pretty much the exact same? The only thing that is different is the x coordinate changed from a positive to a negative. Sorry, the y coordinate. Geez, oh geez, okay. So a quick way you can actually kind of do this is that when you're reflecting over the x-axis, right, your x coordinate actually stays exactly the same, and then your y coordinate just becomes the opposite. So if it was +5, it went to a -5. If your y coordinate was a -10, it would go to a +10. That's just the rule for reflecting over the x-axis, okay? Now let's see, for point B, I'm gonna reflect it over the y-axis. So let's find point B. Here's point B. So point B is from the y-axis. Remember, the y-axis goes up and down. From point B, it's 1, 2, 3, 4, 5 boxes to the right of the y-axis. So B prime is going to be 5 to the left. 1, 2, 3, 4, 5. I'll plot that point, B prime, and B prime looks like it's at -5, +7. So -5, +7. Again, if you compare the pre-image point, point B, and the image point B prime, they're pretty much exactly the same. The only thing that changed was that +5 went to a -5. So when you reflect over the y-axis, the y coordinate or the y value is staying the same, right? 7 and 7 stay the same, but the only thing that's changing to the opposite is the x coordinate, okay? It went from a +5 to a -5, all right? Now your last two here. So point C, now it says M, and you're like, hold on, miss, there's no M axis or anything like that. It's saying you're gonna reflect point C over line M. So we gotta go look for line M here. So line M, you guys see, it's actually this line right here that I'm going over in red, okay? That's line M. So if I'm gonna take point C, which is right here, that's 1, 2, 3 units to the left of line M. So C prime is gonna be 1, 2, 3 units to the right of line M. Okay, that's gonna be C prime. So C prime is at 9, -4. So 9, -4. And since line M is just some random line drawn on my x-axis, there's no rule for line M, right? You can really only have those rules when you're reflecting over the x or y axis. Okay. All right, and last one, we're actually gonna cheat a little bit. So if D is 4, 4, and they're asking for D prime, and they want me to reflect it over the x-axis, remember in the first example when we reflected over the x-axis, the only thing that changed was the y-coordinate. It went from a +5 to a -5. So that means D prime, my x is gonna stay the same, it's 4. I'm gonna change that +4 to a -4 though. That's a quick shortcut we can use, okay? So if I go ahead and plot 4, -4, 4, -4, that's right here, D prime. Does it look like D got flipped over the x-axis here and ended up at D prime? Yeah, it does. So we kind of skipped out on the counting there. We just applied that rule that we learned about in section A there, okay? All right, and then last but not least, this last section here, guys, okay? Actually, we're gonna skip this last section. Don't worry about section 3 here, so you guys can go ahead and cross that off, okay? If you flip on the back side, translations, I think, are probably the easiest transformation. So I got the hard one over with, okay, your reflections. Translations, you're just shifting and sliding, right? But what's important to understand is the notation, right? So if you look at number 1, it says translate the following, and then it gives you a big capital T, followed by these pointy brackets. Then you have numbers inside of the bracket, right? That capital T, I'm sure you guys can guess, that just means we're translating, right? That's just indicating the type of transformation that we're doing, okay? The vector brackets, that's going to dictate what direction we're shifting our shape in. So the first number is going to dictate whether we're going left or right, right? That's going to be our x, and we know on the x-axis that dictates left and right direction, okay? The second number is going to be our y, and that's going to dictate whether our shape is moving up or down, okay? So if I look for my first example, it says we're going to translate triangle JKH by a vector of 2, -3. So that means I'm going to take each point of my triangle, I'm going to shift it over +2 units and then down 3 units, okay? So if I go ahead and do point K first, I go over 2, 1, 2, and then down 3, 1, 2, 3. I'll plot my point. That's going to be K prime, okay? H, same thing, so over 2 dots, 1, 2, down 3, 1, 2, 3. That'll be H prime. And then J over 2 dots, 1, 2, and then down 3, 1, 2, 3. That'll be J prime. And then we're just going to go and connect our dots here. And it should just look like that your shape shifted over a little bit, right? If you want to shade it in, you can. Make it look a little nicer. Okay, that's fine too. Okay. All right, now my next one, it says I'm going to translate triangle EFG by a vector of 6, 0. So 6 means I'm going to shift each point FGE 6 dots over. 0 means I'm not going to actually move it up or down. I'm just going to shift it over 6 dots. So F, if I shift it over 6 dots, 1, 2, 3, 4, 5, 6. Here's my F prime. G over 6 dots, 1, 2, 3, 4, 5, 6. Here's G prime. And then E over 6 dots, 1, 2, 3, 4, 5, 6. That's E prime. Go ahead and connect your dots. And again, it should just look like that it got shifted over by 6 units there. We did not move it up or down because that second number 0 indicates that you're not moving it up or down, okay? Now your last one, okay, we're going to translate triangle LMN by a vector of -3, -1. So that means I'm going to take each point of my triangle, shift it backwards 3 dots, and then down 1 dot. So point M, if I go backwards 3 dots, 1, 2, 3, down 1, my point M is going to end up here, and that's okay that it's in my pre-image triangle, not a big deal. Okay, take point L, backwards 3 dots, 1, 2, 3, down 1, that'll be L prime, and then N, backwards 3 dots, 1, 2, 3, oops, and then down 1, oops, I almost forgot that, and then there's N prime. So let me erase that, okay? And I go ahead and connect my dots, and it should look something like that. And they overlap a little bit, and that's totally fine, okay? As long as it looked like it shifted the proper vector, we're good there, okay? All right, section 2 says determine the translation rule from the pre-image and image. Okay, well, if we look at A, right, they're giving me the pre-image, point A, and they're giving me the image, A prime, and they're just saying, hey, how do we get from A to A prime? Well, how do I get from a -4 to a -1? We're just adding 3 units, right? So my rule is going to be x plus 3, because all I did to get from the -4 to the -1, we add 3 units. Then how do I get from a +1 to a +3? Well, that's just adding 2, right? So my y rule is going to be y plus 2. How you write that in vector notation? You just take the integer that follows the x and the y. So my vector notation will be 3, 2. Okay? For B, again, they're giving me the pre-image point A, the image point A prime. So first thing I want to compare are my x coordinates. So how do I get from a 7 to a 3? I'm just subtracting 4, right? So my x rule is going to be x minus 4. And then my y, I get from a 1 to a 0. That's just subtracting 1. So my y rule is going to be y minus 1. And again, my vector notation, just take the integers that follow the x and the y. So just make sure you're taking the minus signs there too. That'll be a -4, -1. Okay? Now finishing this off, guys, okay? Given a translation rule, determine the missing point. So it's back to just solving for your image and pre-image, kind of like how you guys did last week. Okay, so my translation rule here is x minus 6, y minus 1. They're giving me the pre-image. So to solve for my image, right, pre-image is like your input. So we're going to go ahead and input those numbers into my rule. So I'm going to plug in a -1 for my x, because that's my x value. Plug in a 2 for my y, because that's my y value. -1 minus 6 is a -7. And then 2 minus 1 is a 1. Okay, I'm going to actually do the ones where they give us the pre-image first, so you guys can kind of just get the hang of that. So I'm going to skip B for now. I'm going to go to C. Now they're actually just giving you guys the rule in vector form. So again, the little brackets here, the -1, -2, that's just telling you subtract 1 from your x coordinate and subtract 2 from your y coordinate. So if I go ahead and subtract 1 from my x coordinate, well, 9 minus 1 gives me 8. Okay, I'm going to subtract 2 from my y coordinate, so -5 minus 2 gives me a -7. Okay, now the last two, B and D, is where you have to work backwards, right? They're giving you the image and they're saying, hey, figure out what the pre-image is or figure out what the input is. Okay, so in this case, I'm just going to set my rules equal to the x and the y. So I'm going to set my x coordinate rule equal to my x coordinate point. Well, that's easy. It's just saying x is equal to 8, right? The x's didn't change here. And then I'm going to take my y coordinate rule and set it equal to my y value. So what number minus 4 is equal to the -5? I can solve that by adding 4 to both sides. And I get y is equal to -5 plus 4, which is a -1. So that means my pre-image for my y coordinate was -1 there. Okay. Now, same thing with my vector notation. So again, this kind of just translating to x plus 5, comma, y, right? Y plus 0 if you want to write y plus 0, but just we're not changing the y. Okay. So again, I'm going to take that x coordinate rule, x plus 5, set it equal to my x coordinate. So x plus 5 equals -1. I can solve by subtracting 5 on both sides, and I get x is equal to -6. So that'll be my x coordinate for my pre-image, and then my y's don't change, right? So my y coordinate here is -7. That means my y coordinate, my pre-image, was also -7.